In the last lecture, we learned how to name aldehydes and ketones. Now we're going to learn what reactions aldehydes and ketones can undergo. Remember that alcohols, primary alcohols, can be oxidized to give aldehydes. Secondary alcohols can be oxidized to give ketones. So now we're going to investigate what reactions aldehydes and ketones can undergo. So it turns out that aldehydes, which, to review, aldehydes have this functional group, can be oxidized to give carboxylic acids. Now hopefully your functional groups are becoming easier to remember since you review them all the time, right? So carboxylic acids have a C double bond O, OH. So aldehydes can be oxidized to give carboxylic acids. Ketones cannot be further oxidized. So let's look at an oxidation reaction of propanal. So Al tells you that it's an aldehyde. The prop tells you it's 3 carbons. So the condensed structural formula of propanal looks like this. You oxidize that. Remember that O in brackets means oxidizing, just a general oxidizing reagent. So when you oxidize propanal, you end up with propanolic acid. So this is the second definition of oxidation that I gave you earlier, the addition of oxygen. So what you've done in this reaction is inserted an oxygen between this carbonyl carbon-hydrogen bond. So we now have an oxygen here. So aldehydes can be oxidized to carboxylic acids. And we'll see this again with propane dial, sorry. So since propane dial has 2 aldehydes, you can see how when you oxidize this, you'll get 2 carboxylic acids. So this makes a dioic acid. So this would be propane dioic acid. Now ketones, remember I said cannot be oxidized. So if you have, say, cyclobutanone, and you try to oxidize that, you will get no reaction. So ketones cannot be oxidized. So anytime you see a ketone and an oxidation, you'll get no reaction. So on the next page, I have a few reactions that involve aldehydes and ketones and their oxidation. So I want you to go ahead and hit pause and try and complete those reactions. Okay, so hopefully we got the same products. The first reaction is an aldehyde. So it's propanal getting oxidized to propanoic acid. The second reaction is butane diol getting oxidized to butane dioic acid. The third reaction is a ketone, so it can't be further oxidized, so NR is what you'd write. And then the fourth reaction, 2-methylpropanal gets oxidized, yeah, that was Ethan, to 2-methylpropanoic acid. So remember that oxidation. We've seen 2 examples of oxidation. The first occurred with alcohols, and that was the loss of hydrogen. Now we're seeing the second definition of oxidation in terms of organic chemistry as the addition of oxygen. So aldehydes being oxidized to carboxylic acids, this is an example of oxidation. Now, aldehydes and ketones can undergo reduction as well. So, reduction, just like oxidation for organic chemistry, has 2 definitions. The first definition is the gain of hydrogen Or, second definition is the loss of oxygen. And that's just an O. So, let's look at reduction for aldehydes and ketones. So we're going to have propanal, which is a 3-carbon aldehyde. When you see H2, this means a reduction. So these are the reagents that you'll see for reduction. H2 and platinum, PT. Platinum is a catalyst that's needed for hydrogenation to occur. So, when you have an aldehyde or a ketone in the presence of hydrogen and a catalyst, the bond that will change is the carbonyl. So I'm highlighting the carbonyl. You're going to have hydrogen added across the carbonyl bond, and then the double bond no longer is in place. So this is kind of the reverse of oxidation of alcohols. So we're doing the reverse. So your product will look like this. And I'm going to keep my color coding. So we'll have L, and then off of this, we'll have H, and H. So you've taken an aldehyde and converted it to this would be a primary alcohol. So aldehydes can be reduced to form primary alcohols. Let's look at what happens to a ketone. 2-pentanone, so it has 5 carbons and a ketone on the second carbon. Again, with these reduction reactions, and we know it's reduction because of these reagents. So we're going to be adding hydrogen across this carbonyl, and our product will look like this. So you've taken a ketone and converted it to a secondary alcohol. And that's reduction. So on the next page, I have some reduction reactions. I want you to hit pause and complete this. Okay, so hopefully you got the same products that I did. The first reaction is an aldehyde going to a primary alcohol. So when you complete these reactions, you can always step back and say, okay, what functional group did I start with? I started with an aldehyde. So if it's a reduction reaction, then I should get a primary alcohol, which I did. So it's just a way of double checking yourself. Now the next reaction, I kind of mixed it up for you. I have a ketone and an aldehyde. Now I would never expect you to name this with both functional groups present. So don't worry about trying to name it. But I just wanted to demonstrate that if an aldehyde and a ketone were in the same molecule, they certainly would both be reduced with this hydrogenation. So you would get from this aldehyde here, you would get a secondary alcohol. Or from this ketone here, you would get a secondary alcohol. And this aldehyde here, you would get a primary alcohol. Now, the third reaction that I have, a lot of students are quick to write NR because we just learned previously that oxidation, ketones can't undergo oxidation. Be careful on this one. Remember, we're talking about reduction. So you have a ketone, and when you see these reagents, remember that you're adding hydrogen across the carbonyl bond. So H goes there, H goes there. Because you have a carbonyl, certainly this reduction can take place. So you end up with a secondary alcohol. And then the last one, you start off with an aldehyde. So Aldehydes can undergo reduction to give primary alcohols, which is what I have. So the reactions that we've just learned for aldehydes and ketones, I want you to be very careful with these. We talked about oxidation of aldehydes and ketones. Remember that aldehydes can be oxidized. I'm just going to summarize this. Aldehydes can be oxidized to carboxylic acids. Ketones cannot be oxidized, so no reaction. Aldehydes can be reduced to give primary alcohols. And ketones can be reduced to give secondary alcohols. Fix this one. Okay, so CH2. So be careful. On the exam, all of these will be mixed together in terms of the reactions. So we're going to have the oxidation reactions that we saw from alcohols, also the oxidation reactions for aldehydes and ketones, and then reduction reactions of aldehydes and ketones. So just keep all of this in mind. They will be mixed together. So, if you want to work on a study sheet where you just draw up structures. So like this, oxidize that. What about this structure? To oxidize that. Well, what if I took the same structure and subjected it to this? What would my products be? Take this, oxidized it. What about, oops, skip the page. What about this one? Can you oxidize that? So, this sheet that I've given you just a few examples of practice reactions, everything's mixed together. You can make photocopies of this and practice this over and over and over again just to get in the habit of seeing oxidation and reduction and the different functional groups, alcohols, aldehydes, and ketones. We're going to have 2 more reactions that we learn in this unit, and again, they will be thrown into the mix. So if you have this reaction sheet and you practice and practice, you are more likely to get a better grade on the reactions portion of this exam. So practice, practice, practice. So back to the notes. We're going to talk about how to name carboxylic acids now. So I've given a few names of carboxylic acids and the reactions that we just talked about to kind of give you a preview. But hopefully by now these are becoming easier. You kind of recognize that there's a system and that as long as you have the basics from page 20, you probably can already name carboxylic acids. But I'll go over them to clarify. Now, so remember that carboxylic acids have the C double bond O, so carbonyl is an OH. That's a carboxylic acid. The IUPAC system of nomenclature for carboxylic acids, always, always, always find the longest continuous chain of carbons, name that as your parent. So this chain of carbons would have to have your carboxylic acid in it, and then change the ending to oic acid. So I'm going to circle my parent in red. So this is my parent for my example. The carboxylic acid is always going to be at the ends, just like aldehydes. So always at the end. Because of that, the carboxylic acid will always be number 1. Since it's always that way, you don't have to say it. So you don't have to say 1-ethanoic acid. So the name of this molecule is just ethanoic acid. So it's 2 words. Your common nomenclature kind of restricted since we don't know that many roots. Remember, the roots form is 1 carbon, a set is 2 carbons. So this example has 2 carbons. So that's going to be a set plus ic acid. So a set, so acetic acid. You guys probably have this in your pantry. This is vinegar. So acetic acid. The other common name that you learned from your orange flashcards, which I hope you're still practicing those, this is benzene with the carboxylic acid. This is benzoic acid. Okay. We've seen examples of the dioic acid already. The IUPAC system of nomenclature for dioic acids is, no numbers are necessary, sorry. So it's just alkane dioic acid. The acids will be at the end of the molecule. So for instance, this molecule, which is a dioic acid, would be named propane dioic acid. Now, alpha, beta, and gamma, these symbols that I have here, these are used to indicate what carbons on the carboxylic acid are bearing something. For instance, you might see a facial cream that says, oh, it has alpha hydroxy acids. So this facial cream is the best because it has alpha hydroxy acids. Well, you guys can draw out an alpha hydroxy acid, believe it or not. So you have this carboxylic acid. A lot of times carboxylic acids, their slang term is just acid, especially when referring to organic chemistry. So you hear the term acid, it's most likely talking about carboxylic acid with regard to organic chemistry. So I have this carboxylic acid and these carbons. I'm just going to draw a few carbons. So when they say alpha hydroxy acid, they're saying that the alpha carbon, which is right here, has an OH coming off of it. If they said beta hydroxy acids, the hydroxy would be coming off of this carbon instead of this carbon. Gamma would be this carbon. So you have to be careful with this nomenclature. It's kind of a common nomenclature of referring, instead of using numbers, we're using these Greek symbols. So I could give you a question like this. True or false? N2-hydroxy pentanoic acid, the OH is on the beta carbon. Well, this molecule that I have written here is 2-hydroxypentanoic acid. We can see that the hydroxy is in fact coming off the alpha carbon. So this statement is false. So be careful when you're using alpha, beta, and gamma. A lot of students have a tendency to call the first carbon alpha, which is not correct. If you want to think about that, the first carbon has as many bonds as possible. There's no way it could have a hydroxy coming off of it because that would be 5 bonds to carbon. So carbon 2 is where the common reference system works. Alpha, or starts alpha, beta, and gamma. Okay, so on the next page I have examples, structures of carboxylic acids that can be named using IUPAC nomenclature. So I want you to hit pause and name these structures. Okay, so the first structure is 5-phenylheptanoic acid. So the carboxylic acid always is numbered 1, so That's why the phenyl gets numbered 5. So practice, practice, practice your blue flashcards. The next structure is 3-bromo, 2-ethyl butanoic acid. So the bromo is on the beta carbon, while the ethyl is on the alpha carbon. Just to review that reference system. The next structure, remember that this is an ether. And ethers aren't named by adding a suffix to your parent, they're named by adding a prefix. So if you just have CH2, CH3 coming off of a chain, it would be ethyl, but since the O is there, it's ethoxy. So 2-ethoxybenzoic acid, or you could also say O-ethoxybenzoic acids, ortho. The next structure, a lot of students think that the longest continuous chain of carbons there is 4, but it's actually 5. So it's 2-ethyl pentanoic acid, and the ethyl is coming off which carbon? The alpha, beta, or gamma? It's the alpha carbon. The next structure is a dioic acid, and it's named 2-methylbutane dioic acid. You could conceivably just say methylbutane dioic acid because the methyl would have to be coming off the second carbon, but I will accept both names, so either methylbutane dioic acid or 2-methylbutane dioic acid. And then the last structure is 2-methylbutanoic acid. So practice, practice, practice to your nomenclature. Learned a lot of functional groups in Unit 4 so far. Okay, so solubility of carboxylic acids. Carboxylic acids with 4 carbons or less are soluble in water. So that's kind of the magic number with organic compounds. So we'll see this in lab coming up in the next few weeks. So we've gone over quite a few things in this lecture. Aldehydes and ketones. We've talked about how they can undergo oxidation reactions or reduction reactions. And that's typically very confusing for students. So I want you to practice, practice, practice those reactions. Work on, a practice reaction sheet. We also talked about nomenclature for carboxylic acids. So we talked about IUPAC, common, and dioic acids. So practice that nomenclature as well. It's easy to think you have a handle on this nomenclature when you're just working on specific functional groups. It's very easy to say, oh yeah, I get carboxylic acids. But then once you have carboxylic acids combined with aldehydes, ketones, alcohols, thiols, ethers, it gets confusing. So make sure you practice your pink book, practice naming everything mixed together, because on the exam it will be all mixed together. And lastly, we talked about solubility of carboxylic acids. So keep these in mind. So I want you to do your homework. And I also want you to work on your labs. The labs, aldehydes and ketones, have reactions. So you can complete a lot of those reactions now too, since we've talked about that. So until next time.